A warm welcome. This is Electric Energy Generation, Utilization and Conservation course, lecture 1.2, focusing on the topic photometry. Photometry involves the measure of the candle to power of the intensity of a given source. The candle power of a given source in a particular direction can be measured by the comparison with the standard or substandard source. This is more or less near like benchmarking process. That is, we have a standard source whose intensity is definitely a known one. With that standard source, we have to compare the source which we are using. That can be measured with the help of, because illumination level has to be measured, so both the illumination level has to cancel out. This is the main concept we are going to consider. The primary standard is normally defined based on the brightness of a body, that is a black body, maintained at freezing temperature of the platinum. Let us see how the comparison is made. The test source or the lamp is compared with the laboratory standard. Standardization of lamp is by voltage rating, current rating and wattage. These measurements comprise the photometry. They employ a photometric bench with a photometric head, which is an opaque screen. These measurements involve comparing the test lamp with the standard lamp. There are three processes by which we can compare the illumination of the test lamp with the standard lamp. First one is by varying the position of the comparison lamp, that is the standard lamp. Second, by varying the position of the test lamp. And third one is by varying the position of the screen, that is the photometric head. Actually, in the first process, when we are varying the position of the comparison lamp, the position of the test lamp is kept constant. It will not be varied. And the screen will also be placed at a constant, the position of the screen will not be changed. In second method, position of the standard lamp as well as the screen is kept fixed, and only the position of the test lamp is varied. In third method, while varying the position of the screen, both the lamps will be kept at a fixed position, they will not be varied. And the measurement is complete when the bench is getting balanced. What is the meaning of balanced here? Actually, it is getting balanced when the two sides of the screen are equally bright. They have to be, there should not be any reflection from one side to the other. Both the sides should be equally bright. This is how the comparison is made in the photometric bench. Let us see about the photometer. The photometer bench essentially consists of two steel rods with 2 to 3 meters long. This bench carries stands or saddles for holding two sources, that is the test and the standard sources, standard lamps. The carriage for the photometer head, it has to be placed in between the test lamp and the standard lamp, and any other apparatus are employed in making the measurements. Whatever we are using for measurement purposes, those have to be accommodated in the photometric bench. The photometer bench should be rigid so that the source being compared may be free from vibration. Actually, it should not have any vibration, and it should be, when it is fixed to the photometer bench, it should be rigid. It should, the vibration should not cause any changes in the illumination effect. So since the source should be fixed in its position, the it should be rigid in nature. Next, the photometer head should be capable of moving smoothly, and the photometer head acts as a screen for the comparison of the illumination of standard lamp and test lamp. Now we can see on the left side the standard source is present, on the right hand side the test lamp is present, in between photometer head or screen is present. Now how the measurement is made? The distance between the standard lamp and the photometer head is measured, as well as the distance between the photometer head and the test lamp is measured. So we can see the distance. This is what the measurements, the length measurement can be made. In here, the candle power of the standard source is directly proportional to the L1 square, and the candle power of test source is directly proportional to L2 square. So while you are taking the ratio, automatically we can see that they are proportional to the ratio of their respective squares of the distances, and which is equal to S into L2 square by L1 square. This is what is the principle of photometric operation. Next, let us see about the photometer head. That is how the opaque screen is present, how the lightings will be falling on which, how the comparisons are made, and in what procedure the photometric bench is getting activated. Let us see here, we have a standard lamp. We have two different types of photometers here. One is Bunsen grease spot photometer and the other one is lumen Borden photometer. While you are considering the Bunsen grease spot photometer, we have a standard lamp here, we have a test lamp here, and these are reflecting mirrors. This is a paper screen with the spot, right? So now what you are going to do is you have to vary this screen. So this screen is varied. As this screen is varied at a distance, this L1 and L2 gets changed. This is the third method. We are moving the screen. When you are moving the screen, the lamp will be putting its light and this lamp will have its reflection over the mirrors. We can see that the reflecting mirrors are placed in a V shaped. So now the screen should be placed at a distance where both the illumination level gets equal. That is where the brightness at this side of the screen and the brightness of this side of the screen are getting equal. Only at that position L1 and L2 have to be placed. At that time we can say how the illumination level has to be. Based upon the standard lamp, the test lamp can be standardized in this manner. In Bunsen grease spot photometer, lumen Borden photometer is an advantageous one through which you are going to view the brightness level compensation with the help of a microscope. Here what we are going to consider is you are having the S1 source here and the S2 source here. Light from S1 and S2 source are made to fall on this screen. So while the light falls on this screen, it gets reflected towards this mirror. This is a screen and here we get have a mirror. And after coming here, it is getting reflected to this crystal. It is the lumen Borden crystal. The crystal. Here we can see the light is getting reflected in this mirror and then again it is getting reflected from this mirror and then it is going towards the crystal, and through the crystal after getting reflected from the crystal, it is moving towards the microscope. But in case of S2, that is the test source, we can see that light from S2 is moving towards the screen, getting reflected, and it reaches this mirror. And after getting reflected from this mirror, it passed through this lumen Borden head, where this crystal, where it is not getting reflected, rather than it is moving through the crystal. While you are considering the light from S1 lamp, it is getting reflected at all cases including the crystal. But in S2 case, it is not getting reflected from the crystal. It is passing through the crystal. This is the main thing. And also you can see that the light from S2 is passing through the middle one, and the light from S1 is getting reflected on the sides with S2 in middle. So we can see almost a circular reflection here. So this way of pattern we can see. So now the outside, the circle outside will illuminate the light from S1, and the middle one will be, the center's ring will illuminate the light from S2. Now what we have to do is we have to adjust the lamps S1 or S2, either S1 or S2 has to be adjusted. When both are getting when that lamp is getting adjusted, the condition is the entire brightness level, that there should not be any segregation between these two circles. It should be a complete single circle with equal brightness level. So this part as well as this part, they should have a equal brightness level. In this way we have to view through the photometric head. Only at that case we can say the test lamp is getting standardized. And this is a photometric bench. In normal cases we are going to apply the EMF here, and here we can see the light is falling over the negative contact, and here normally we used to polish that negative contact with the varnish or something else, and after that below the negative contact we have the base plate, and after the base plate we have the selenium layer, and after that the cadmium oxide layer, and finally electrically conducting layer. In this way the photometric bench can be activated, the source can be activated, and enough illumination can be measured for the test lamp source. Thank you.